myself, Dr. Chaitanya Krishna, professor in the ECE department. Here, I am going to deal the topic is a coordinate system in the subject electromagnetic fields and waves. Here, why we can dealing this topic in that particular subject is a whatever the electromagnetic field components, whatever the electromagnetic field, we can analyze that electromagnetic field by using these coordinate systems. These three coordinate systems. Here, basic these three coordinate systems are the Cartesian coordinate system and cylindrical coordinate system and spherical coordinate system. Now, based upon these three only, we can analyze the electromagnetic fields where the signal strength in the Cartesian, cylindrical, spherical coordinate system. Now, the basic coordinate system is a Cartesian coordinate system. Here the Cartesian coordinate system components or coordinates are the x comma, y comma, z, and this Cartesian coordinate system we can also call as a rectangular coordinate system. Why we can call as a rectangular coordinate system? The shape of this coordinate system is a rectangular shape. Here the Cartesian coordinate system Here the Cartesian coordinate system, x and y and z. If we can take the any point on that particular coordinate system that has the x component as well as y component as well as z component. Now, by using this Cartesian coordinate system, in the Cartesian coordinate system is a vector form is a bar is equal to ax bar plus ay bar plus AZ. Now here, this means here AX means unit vector in the x direction, unit vector in the y direction, and unit vector in the z direction, and the magnitude in the x direction, and magnitude in the y direction, and magnitude in the z direction. This is a representation of a vector in Cartesian coordinate system. Here the Cartesian coordinate system coordinates are the x comma, y comma, z are there. The limits of this coordinates are the minus infinity to plus infinity for x and y and z. Minus infinity to plus infinity. This is about this Cartesian coordinate system. The next one is a cylindrical coordinate system. The cylindrical coordinate system, the coordinates are the rho comma, phi comma, z. Rho comma, phi comma, z. Now, here the next one is a cylindrical coordinate system. The cylindrical coordinate system, it means the shape of the coordinate system is a cylindrical shape. If we can take any point on this cylindrical coordinate system, for example, we can take a P point that has a component of the rho and phi and z. Now, what is the rho component and what is the phi component and what is the z component? Here, the rho component is a radius from the z axis to whatever the point we can take on the surface of the cylinder. The radius is we can call as a rho. The next one is what is the phi means? Phi is a azimuthal angle on xy plane. Azimuthal angle on xy plane from x axis. Here, the phi is the azimuthal angle on xy plane from x axis, and z is the same as the Cartesian coordinate system, z direction component. This is the cylindrical coordinate system components, and limits of the cylindrical coordinate system components are the rho limits, the radius from the z axis to surface of the cylindrical. We can have the limits from 0 to infinity, and azimuthal angle limits from 0 to 2 pi, and z-axis limits is the z component limits is the 0 minus infinity to plus infinity. This is a cylindrical coordinate system component. The vector representation in the cylindrical coordinate system as the a bar is equal to a rho bar plus a phi bar plus az. Here the rho direction, the magnitude is a rho, phi direction, the magnitude is a phi, and z direction, the magnitude is az. Now the next coordinate system is a spherical coordinate system. The spherical coordinate system is a the next coordinate system is the spherical coordinate system. The spherical coordinate system coordinates are the r comma theta comma phi. The representation of this spherical coordinate system is this one. Here, what is r value and what is the theta value and what is the phi value? Now, r value is the radius of the sphere from origin radius of the sphere. Radius of the sphere means here whatever the point we can take on the surface of the sphere from the distance from the origin to that point, we can call it as r. Next one is the theta value. This is the angle from the z-axis to whatever the point we can take on the surface of the sphere. That angle we can call it the theta. And next value is the phi. Phi value is the same as the whatever we have discussed in the cylindrical coordinate system, that is the azimuthal angle on xy plane from the x-axis. This is a spherical coordinate system. Here, the spherical coordinate system coordinates limits are the r limits from 0 to infinity and theta limits 0 to 5 and phi limits 0 to 2. And a vector representation of this spherical coordinate system, a bar is equal to ar bar plus a theta bar plus a phi. Now, based upon these three coordinate system components, now we can how to convert one coordinates into the another coordinates. How to convert one coordinates into the another coordinates. Now we can see. Here, the first we can represent. We can take one coordinate system. For example, is the x component and y component and z component. Here we can take one point. Here the p of x comma y comma z, that is equal to p of rho comma phi comma z, and that is equal to r comma theta comma. If we can take one point on any coordinate system that have the three coordinates x comma y comma z, the same as the rho comma phi comma z and r comma theta comma, we can take this point. Now, based upon the definition of all these three, we can take and we can represent all these definition in this diagram. Now, first one we can represent the cylindrical coordinate system. What is the rho? Rho value from z-axis to whatever the point is there, that radius is we can call as a rho, and on the xy plane, whatever the angle is there, that angle we can on the xy plane. From the x axis to that point, the angle is a phi, and next value is the z direction coordinates, the z component. Based upon this one, we can write as a x component and y component. Here this x and this is a y from here to here and here to here. Means here the y means here also y, here also x. Now spherical coordinate system components, according to the definition, from the origin to point, whatever the point we can take, that value is the r value, and from the z axis to the point, angle between these two we can call as a theta. Now in this one diagram, we have all these three coordinate system coordinates and these three coordinate system values. Now we can convert one coordinate system into another coordinate system by using this diagram. Now we can convert the Cartesian coordinate system into cylindrical coordinate system or cylindrical to Cartesian coordinate system. The first one, we can convert the Cartesian cylindrical coordinate system components into Cartesian coordinate system components. Now we can take here also rho. Now based upon this triangle, and this is the based upon this triangle, rho square equal to, based upon this triangle, rho square equal to x square plus y square. Then rho equal to under root of x square plus y square according to Pythagoras. This is a rho value. Rho value is a cylindrical value in terms of Cartesian coordinate systems. Next, tan phi. Based upon this triangle only, what is the tan phi? Tan phi value is a y by x. Now phi is equal to tan inverse of y by x. Tan inverse of y by x. And this is the phi is the cylindrical coordinate system component. In terms of y and x is the Cartesian coordinate system component. The next value is the z value is there. The same z value is there in the Cartesian and cylindrical coordinate system. Now from Cartesian coordinate system or cylindrical coordinate system into Cartesian coordinate system. Now Cartesian coordinate systems into cylindrical coordinate system we can convert by using this diagram only. By using this triangle, we can convert from the cylindrical coordinate systems into Cartesian coordinate system. Now, here, what is the sin phi from this diagram? Sin phi is equal to y by rho. Now, y is equal to rho sin phi. Y is equal to rho sin phi. Same as the cos phi. Cos phi value x by rho. Now x is equal to rho cos phi. Same as the z value is z. Here this is a conversion from the Cartesian coordinates into cylindrical coordinates and cylindrical to Cartesian. Now the next one, we can convert the spherical coordinates into cylindrical coordinates or cylindrical coordinates into spherical coordinates by using this triangle. We can convert cylindrical coordinates into spherical or spherical coordinates into cylindrical. From this one, what is the r value? According to Pythagoras, from this triangle, r square equal to rho square plus z square. Now r is equal to under root of rho square plus z square. Now the next one is what is tan theta? Tan theta equal to rho by z. Theta equal to tan inverse of rho by z. Here theta and r are the spherical coordinate system component that will be represented in the cylindrical coordinate system component. The next value is a r comma theta comma phi. Phi value is the same as a cylindrical coordinate system. Whatever we can take the value, the phi value is the same as a phi value. R we can write as a tan inverse of y by x also. Tan inverse of y by x or tan inverse of y by x. In the cylindrical coordinate system and spherical coordinate system, phi value is the same. That's why we can write as a phi. Phi value is the same as a phi. Now cylindrical coordinate system components and spherical coordinate system components are there. Based upon this one only we can analyze the signals in the different various coordinate system, and phi value is phi. Next, now